While you're sitting in your chair right now, a silent piece of dark rock the size of a city skyscraper is quietly leaving our cosmic neighborhood. Nobody saw it arrive, nobody gave it a name until it had already whipped past our planet, and nobody knows where it will end up next. It slipped past our most powerful space cameras without making a single sound. For weeks, the human race went to sleep every night, completely unaware that a giant cosmic bullet had just missed our home. If you love exploring the quiet mysteries of the deep universe based on real science without any fake drama, tap that subscribe button right now. When you join this community, you become part of a group of curious minds who want to see what is really out there in the dark. Most of us grow up believing that the solar system is a completely closed and peaceful room. We imagine the sun sitting directly in the center like a giant warm fireplace, while 8 planets circle around it on clean, predictable tracks year after year. We are taught that outer space is mostly empty, peaceful, and still, with everything staying neatly in its assigned lane. It feels safe to assume that nothing unexpected ever breaks through that giant boundary. That comforting picture is completely wrong. Outer space is not an empty room with locked doors, but an open ocean with zero walls and violent currents. Billions of rogue wanderers, frozen icebergs, and dark chunks of ancient iron are drifting through interstellar space right now with no home star to hold them back. They do not follow the orbits of our planets, they do not belong to our sun, and they can cut through our solar system whenever they want. For hundreds of years, astronomers believed that interstellar objects would be almost impossible to miss. They reasoned that any chunk of ice or rock from another star system would light up like a giant fireworks, show the moment it got close to the heat of the sun. Scientists calculated that ice on the object would instantly boil into gas, creating a glowing cloud and a massive tail stretching millions of miles across the night sky. Under that old theory, Earth would always have plenty of warning before anything strange passed through our neighborhood. That long-held belief fell apart completely on October 19, 2017, at a mountain observatory in Hawaii. An astronomer named Robert Warwick was analyzing regular sky surveys from the Pan-STARRS telescope on top of Haleakala when he spotted a faint speck of light moving at an impossible speed. When scientists ran the math on its flight path, their computer models broke because the orbit was not an oval like regular solar system rocks. It was a steep, open curve, meaning this object had come from deep interstellar space, crossed right past Earth, and was already rushing away into the dark before anyone even knew it existed. The object was officially named Oumuamua, a Hawaiian word that means a messenger reaching out from the distant past. When scientists worked backward to trace where it had been, the timeline sent a cold chill through the astronomical community. Oumuamua had actually made its closest approach to the sun back in September, and it had quietly swept past Earth a few weeks before anyone detected it. It had moved through our inner solar system completely unseen by thousands of ground telescopes and orbiters, slipping right through our entire global defense network. Why did this giant visitor stay invisible for so long? The answer comes down to geometry, speed, and the massive blind spots in human technology. Oumuamua came charging into our solar system almost from the north, arriving from the direction of the bright star Vega at a staggering speed of over 87,000 miles per hour. That is more than 38 kilometers every single second, or roughly 40 times faster than a speeding bullet fired from a military rifle. Because it approached from high above the flat plane where our planets orbit, our normal survey telescopes were simply not looking in that direction at the right time. Most sky scanning programs point their lenses along the orbital highway where typical asteroids travel. Even worse, as Oumuamua made its final dive toward the sun, it came from the direction of daylight, effectively hiding inside the blinding glare of our own star where ground-based cameras cannot look without burning their sensors. When scientists finally managed to point their largest instruments at the object, they expected to see a standard round chunk of dirty ice. Instead, the data revealed something that defied almost every rule of planetary physics. As Oumuamua tumbled end over end through space every 7.3 hours, its brightness changed dramatically by a factor of 10. That wild shift in light meant the object was not spherical at all, but bizarrely long and thin, like a giant cigar or flat pancake, measuring around 400 meters long and only 40 meters wide. In our own solar system, natural asteroids are almost always lumpy, roundish, or shaped like potatoes because gravity pulls them into compact shapes. Finding an object that was 10 times longer than it was wide was unprecedented in the entire history of astronomy. It was darker than fresh asphalt, absorbing over 90% of all the sunlight that hit its surface, which made it practically invisible against the pitch-black curtain of space until it was practically on top of us. Did you realize that an object from another star system was already flying away from us before human eyes ever saw it? Now let me know your thoughts on that in the comments below, and give this video a quick like if you think our space tracking systems need an upgrade. The mystery deepened when astronomers looked for the giant comet tail that was supposed to reveal its presence. There was no dust, no glowing gas, and no visible trail whatsoever. By all classical definitions, An icy object passing that close to the heat of the sun should have unleashed thousands of tons of vaporized water. Yet, Oumuamua remained completely silent and dry, looking for all practical purposes like an inert shard of dark metal or dense rock traveling on a solo journey across the galaxy. Then came the observation that left the scientific world completely divided. As Oumuamua raced away from the sun, researchers tracked its exact trajectory to see if it was slowing down under the pull of solar gravity. It was supposed to lose speed steadily as the sun pulled back on it. Instead, the data proved that Oumuamua was actually accelerating on its way out of the solar system, picking up extra speed without any visible rocket exhaust or evaporating gas pushing it forward. When a regular comet speeds up, the push comes from outgassing, where pockets of subsurface ice boil and shoot out like tiny thruster jets. But if Oumuamua was outgassing enough to cause that extra speed, astronomers should have seen bright clouds of water vapor or carbon monoxide with their most sensitive infrared cameras. They searched with the Spitzer Space Telescope and detected nothing at all. The object was gaining speed from an unseen force, while showing zero signs of physical activity. This impossible behavior led prominent astrophysicists, including Professor Avi Loeb from Harvard University, to consider a radical idea. He suggested that if natural forces could not explain the flat shape, the dark surface, and the mysterious acceleration, we had to at least consider the possibility that Oumuamua was an artificial structure, perhaps a discarded light sail pushed along by the pressure of sunlight itself. While most scientists preferred the idea of an unusual hydrogen or nitrogen ice block that produced invisible vapor, no one could prove a single theory with total certainty because the object was already moving too fast to chase. The most unsettling realization was not the strange shape or the unexplained push, but the mathematical certainty that Oumuamua was not alone. Space is unimaginably vast, and the odds of human telescopes catching the only interstellar visitor passing through our solar system in our lifetime are practically zero. If our cameras spotted one object by pure accident, it means there are likely millions of similar dark wanderers drifting through our solar neighborhood at any given moment. Astrophysicists estimate that our solar system currently holds thousands of these unseen interstellar interlopers at any single second. Most of them are too dark to reflect sunlight, too small to trigger warning alarms, and moving too fast to track with current equipment. They drift between the orbits of Earth, Mars, and Jupiter without making a sound, passing through our home system like ghosts through an empty room before heading back out into the freezing void between the stars. The scary reality is that our planetary defense system was built to look for things we already understand. We have cataloged thousands of near-Earth asteroids that follow regular circular orbits around the Sun, because their predictable patterns make them easy to calculate months or years in advance. But when an object arrives from deep space on a hyperfast plunge, we have no advanced warning system in place to see it coming from behind the Sun. To understand why these objects are so dangerous, you have to look at the energy they carry. Kinetic energy in physics depends on mass and velocity, but velocity is squared. That means if an asteroid is traveling twice as fast as a normal space rock, it hits with 4 times as much destructive force. If it travels 4 times faster, it hits with 16 times the energy. An interstellar intruder moving at 40 kilometers per second would hit Earth with more cataclysmic power than an entire arsenal of planetary-scale weapons. If an interstellar object were on a direct collision course with Earth right now, how much warning time do you think our scientists would actually have to act? Leave your guess in the comments, and be sure to subscribe so you never miss another deep look at what is moving through our skies. Scientists originally thought that finding an interstellar visitor was a once-in-a-century event that human technology had barely been lucky enough to catch. But only 2 years after Oumuamua vanished into the outer dark, another unexpected traveler showed up. On August 30, 2019, an amateur astronomer named Gennady Borisov pointed a custom-built telescope at the sky above Crimea and spotted a bright, fuzzy light moving across the stars at incredible speed. This new object, named Comet 2 Borisov, looked very different from Oumuamua. It had a massive glowing halo and a brilliant tail of gas that stretched for hundreds of thousands of miles, making it clearly identifiable as a comet from another solar system. But the most terrifying detail about Borisov was its raw velocity. It was barreling through our space at over 110,000 miles per hour, or roughly 32 kilometers per second, completely untethered to the gravity of our Sun. When chemical sensors analyzed the gas streaming from Borisov, they discovered that it was packed with huge amounts of carbon monoxide, far more than any normal comet formed in our solar system. That chemical fingerprint proved that Borisov had been born in the freezing outer fringes of a completely different star system, likely orbiting a red dwarf star billions of years ago before a violent gravitational kick threw it out into the galactic wilderness. The discovery of Borisov proved that every kind of space rock imaginable is drifting between the stars. Some are bone-dry shards of metal like Oumuamua, while others are massive frozen bombs loaded with volatile toxic gases. They are the cosmic shrapnel of dead solar systems, shattered planets, and chaotic stellar collisions that took place billions of years in the past, now wandering through the dark Milky Way until they cross paths with our quiet corner of space. Even more shocking is the evidence that these alien space rocks have already struck our planet in recent history without anyone realizing what they were. In 2014, 3 years before Oumuamua was even discovered, a tiny meteor entered Earth atmosphere over Papua New Guinea and exploded in the upper sky with the energy of a small atomic blast. United States military sensors designed to track nuclear detonations recorded the fireball, noting its extreme speed and unusual entry angle. Years later, researchers analyzed that military data and calculated that the meteor, known as CNEOS 140108, had been moving at an astonishing speed of 45 kilometers per second relative to our Sun before it hit our atmosphere. That extreme speed meant it could not have originated from our asteroid belt or outer cometary reservoir. It was an interstellar projectile that had traveled through the galaxy for millions of years before ending its journey in the skies over our Pacific Ocean. When scientists studied how deep the meteor penetrated into the dense atmosphere before exploding, they found that it resisted air pressure 20 times better than typical stony asteroids. That physical toughness suggested the meteor was made of an exceptionally strong material, possibly pure iron-nickel alloy, or a type of ultra-dense cosmic matter formed under extreme gravitational conditions, unlike anything found on Earth. It was an alien world touching our world, entirely unnoticed by the public at the time. To track down physical proof of this visitor, a daring ocean expedition set sail into the Pacific in 2023. Using a specialized magnetic sled dragged across the deep ocean floor, researchers sifted through volcanic sands thousands of feet beneath the waves. They recovered microscopic spheres of strange metal that showed isotopic ratios never before observed in any natural rock on our planet, directly pointing to an origin outside our solar system. Consider what this means for our everyday security on this planet. We live our lives under a thin blanket of air, trusting that our scientists have mapped every major danger lurking in the night sky. But the data shows that microscopic grains, city-sized asteroids, and entire interstellar wanderers are constantly crossing through our orbital path, arriving with zero notice from the deepest regions of uncharted space. Do you feel safe knowing that pieces of other star systems have already entered our atmosphere without early warning from ground observatories? Share your reaction in the comments below and make sure you hit that like button to help spread real space science to more people. The danger from unseen objects is not limited to small asteroids and icy comets. The galaxy is also home to far larger, far darker monsters that can tear through our solar system without giving off a single ray of visible light. These are rogue planets and dead stars, wandering masses that have no sun to light them up, drifting through the frozen void like giant invisible cannonballs. Astronomers now calculate that there may be more rogue planets roaming the Milky Way than there are active stars. When young solar systems form, the gravitational dance between giant gas planets like Jupiter and Saturn is violent and chaotic. During these early orbital wars, millions of newly formed worlds get violently kicked out of their original homes and thrown into deep interstellar space, doomed to wander in eternal darkness forever. These dark worlds produce no light of their own because they have no star to illuminate their clouds. If a rogue planet the size of Mars or Neptune were currently falling toward our inner solar system, our visible light telescopes would not be able to spot it until it was already dangerously close. It would be a pitch-black sphere moving against a pitch-black background, totally invisible until it blocked the light of a background star for a few brief seconds. A collision with a rogue planet is not even necessary to cause total devastation on Earth. Gravity reaches out far beyond the physical surface of any planet. If an invisible rogue gas giant passed anywhere between the orbits of Earth and Mars, its massive gravitational pull would instantly warp the orbits of every terrestrial world. It could pull Earth out of our habitable zone, sending our planet plunging toward the blazing furnace of the sun, or drifting outward into the deadly cold of deep space where our oceans would freeze solid in weeks. Even worse, our solar system has actually survived close encounters with wandering stars in the relatively recent past, and we only discovered it through clever historical detective work. In 2015, an international team of astronomers led by Eric Mamajek discovered that a dim binary star system known as Scholz Star passed right through our solar system outer perimeter, roughly 70,000 years ago. Scholz Star is a tiny red dwarf accompanied by an even smaller brown dwarf, giving off so little light that it is almost impossible to see with the naked eye. But 70,000 years ago, this stellar intruder swept within 0.8 light-years of our Sun, cutting directly through the outer Oort cloud, which is the giant shell of billions of comets surrounding our solar system. At that exact moment in history, early humans were already walking the plains of Earth, painting in caves and hunting for survival. They had no idea that an entire alien star system was quietly brushing past the outer walls of their planetary home. While the red dwarf was too dim to light up the night sky, its gravity was strong enough to stir up thousands of frozen comets, nudging them out of their stable orbits and setting them on new trajectories. Astronomers have also calculated that another star, Gliese 710, is currently heading straight toward our cosmic neighborhood right now. In about 1.3 million years, this orange dwarf star will pass within just 10,000 astronomical units of our Sun, plunging directly through the heart of the Oort cloud. When it does, its intense mass will trigger the most violent gravitational disruption our solar system has seen in millions of years. This is the hidden time bomb that rogue objects leave behind when they cross our solar system. When an intruder plows through the Oort cloud, it acts like a bowling ball rolling through a room full of resting billiard balls. It does not destroy the comets immediately, but it destabilizes their fragile paths. Millions of years later, those disturbed comets slowly begin to fall toward the inner solar system, creating a delayed storm of cosmic impacts that Earth will have to face down the line. If an unseen rogue star passed through our outer comet cloud today, how do you think humanity would handle knowing that a comet shower was heading our way in the future? Drop your thoughts in the comments, and take a second to subscribe if you enjoy these real deep looks into cosmic history. The Oort cloud is one of the most mysterious and dangerous regions in all of astrophysics. It is a massive spherical shell of icy debris that extends from about 2,000 astronomical units away from the Sun all the way out to nearly 100,000 astronomical units, or almost halfway to the nearest star. 1 astronomical unit is the distance between Earth and the Sun, which is about 93 million miles. Because the comets in the Oort cloud sit on the very edge of our Sun gravitational reach, they are barely held in place. Even the gentlest tug from a passing interstellar object or a rogue body can break their delicate balance and send them sliding downward toward the planets. Once an Oort cloud comet starts its long plunge toward the inner solar system, it can take hundreds of thousands of years to reach us, but it arrives with terrifying momentum and almost zero warning time for civilization. The scariest category of unseen intruders are not rogue planets or icy comets, but wandering stellar mass black holes. When massive stars die in supernova explosions, they leave behind tiny, hyperdense cores that hold the mass of several suns, packed into a space no bigger than a mid-sized city. These dead remnants do not give off light, heat, or radio signals. They are absolute voids, moving silently through the Milky Way at speeds of hundreds of kilometers per second. Astronomers calculate that there are roughly 100 million isolated black holes roaming freely through our galaxy right now. Because they do not have companion stars feeding them gas, they do not produce glowing accretion disks. They are entirely black, against the dark backdrop of space, making them the ultimate stealth predators of the universe. The only way we can ever detect a solitary black hole is through a process called gravitational microlensing. When a roaming black hole passes directly between Earth and a distant background star, its intense gravity acts like a natural magnifying glass, bending and brightening the starlight for a few weeks before returning to normal. In 2022, the Hubble Space Telescope confirmed the first unambiguous detection of an isolated rogue black hole drifting 5,000 light-years away, proving beyond all doubt that these invisible titans are actively wandering through space. If a rogue stellar mass black hole entered our solar system from deep space, we would not see it approaching through optical telescopes. We would only know it was there when the outer planets started wobbling in their orbits for no apparent reason. By the time scientists realized that an invisible mass was bending the paths of Neptune and Uranus, the black hole would already be deep inside our system, disrupting planetary orbits and potentially stripping Earth of its atmosphere through tidal forces alone. This is why modern astronomers are racing against the clock to build a completely new generation of automated survey telescopes. They know that our current planetary defense network is full of massive blind spots, and they are desperate to find the dark objects that are crossing our skies before it is too late to track them. The most important new tool in this fight is the Vera C. Rubin Observatory, currently being completed on a mountain ridge in Chile. Equipped with the largest digital camera ever built for astronomy, this facility will scan the entire visible sky every few nights, capturing billions of faint objects and tracking even the smallest changes in brightness. Scientists expect the Rubin Observatory to discover thousands of new interstellar objects, revealing just how crowded our cosmic backyard really is. To catch these objects before they slip away forever, space agencies are already designing rapid response interceptor missions. The European Space Agency is developing a spacecraft called Comet Interceptor that will wait in a parking orbit in deep space for months or years. The moment an unexpected interstellar intruder is spotted diving toward the Sun, this parked spacecraft will fire its engines and fly directly toward the visitor, capturing high-resolution photos and chemical samples up close before the object can vanish into the void. Have you heard about the massive new telescope in Chile that is about to scan the entire sky for hidden objects? Let me know if you want a deeper look at that project in a future video. and hit the subscribe button to stay connected with the latest discoveries. Another major breakthrough in planetary defense is the deployment of space-based infrared telescopes that do not rely on visible light to spot incoming hazards. An object that is as dark as coal and completely invisible to optical cameras will still give off a tiny amount of heat absorbed from distant stars. By looking in the thermal infrared spectrum, space telescopes like the upcoming NEO Surveyor can spot dark asteroids and interstellar rocks based purely on their temperature signature. Putting these infrared detectors into orbit around the Sun instead of keeping them on Earth's surface solves the daylight blind spot that let Oumuamua slip past us. By positioning cameras away from our planet, astronomers can look sideways into the regions near the Sun, catching rogue visitors as they dive inward rather than discovering them only after they are already leaving our neighborhood. Why does all of this matter to you and everyone you love? Because the story of life on Earth has always been shaped by the things that fall out of the sky. 66 million years ago, a single asteroid roughly 10 kilometers wide slammed into the shallow waters of the Yucatan Peninsula, triggering global wildfires, acid rain, and a decade-long winter that wiped out the dinosaurs and 75% of all species on the planet. That dinosaur-killing asteroid was a regular solar system rock traveling at normal orbital speeds. An interstellar object of the exact same size, arriving from deep space at twice or 3 times that velocity, would deliver a blow so cataclysmic that it could boil the global oceans, strip away our ozone layer, and reset the entire biological clock of Earth back to single-celled bacteria. We live on an open cosmic highway, and we cannot afford to look away from the road. Understanding the objects that cross our solar system is not just about avoiding disaster, it is also about uncovering the ultimate origins of life itself. When an interstellar visitor like Oumuamua or Borisov crosses our neighborhood, it carries pristine chemical samples from a completely alien star system that formed billions of years before our sun was even born. Some astrobiologists believe that the basic chemical building blocks of life, such as amino acids, complex carbon molecules, and water ice, may actually travel from one solar system to another inside the frozen hearts of these interstellar wanderers. If alien rocks have been striking Earth for billions of years, it is entirely possible that the spark of life on our world was delivered by an interstellar traveler that crossed our solar system unnoticed during the deep history of our planet. Every time a new telescope powers up, it reveals that our universe is far more dynamic, chaotic, and interconnected than our ancestors ever dared to imagine. We are not isolated on a lonely island safe from the rest of the galaxy. We are part of a massive, swirling ecosystem of stars, dust, and wandering worlds that are constantly trading material across unimaginable distances. The dark object that crossed our solar system in 2017 was a wake-up call for the entire human race. It proved that our technology was barely sharp enough to catch a single glimpse of a visitor from another world before it vanished forever into the black void. It reminded us that the universe does not wait for us to be ready, and that what we cannot see can change our destiny in a matter of seconds. As our instruments get sharper and our eyes turn toward the deep dark, we are beginning to see the true nature of our home. Space is full of silent travelers, ancient messengers, and uncharted shadows that have been moving across the stars since the beginning of time. The next one is already on its way, falling quietly through the frozen silence of the outer rim, waiting for the moment it crosses our path. If you made it this far, make sure you hit that subscribe button right now and turn on all notifications so you never miss another deep investigation into the wonders of space. Drop a comment below telling me whether you think Oumuamua was a strange natural rock or something built by an alien intelligence, and share this video with a friend who loves cosmic mysteries. Thank you so much for watching, and stay curious until next time.